All right, so I'm Miss Kelly, and today I'm going to be going over an example of a project for midpoint and distance. So the objective of this project is to be able to use the midpoint and distance formulas to find distances between points and locations of points in a coordinate grid as related to real-world locations. So our big key here is we're going to use the midpoint formula and the distance formula, and we're going to use it in the coordinate grid. So our setup is that we are on an archaeological dig and we found what seems to be the foundation for an ancient building. Research tells you that two major statues were connected to this ancient building. One stood in the center of the temple, and the other stood outside the temple, exactly twice the distance from the north corner, point A, as it is from the east corner, point B. An image of the plot you made is shown below. Each unit is equivalent to 5 feet. So when we're looking at that, that's super dense. So we need to talk about what it is that we need to do. So step one, let's talk about what's important. So I know that there's two statues and that one was in the center of the temple. So center is middle, and the middle of my temple here is going to be somewhere in this general vicinity, but I need to find the exact location. And then I also know that the other one's outside the temple. So somewhere on the outside, and it's exactly twice the distance from the north corner, so twice the distance from the north corner, which is point A. So twice the distance from point A as it is from the east corner, which is point B. So what that tells me, it is further from A than it is from B, so it's going to be closer to B than A, but it's exactly twice the distance from A than B. So that's telling me that B's got to be in the middle. So I'm looking for my other statue somewhere over here. Well, that's off the grid, so I'm definitely going to need an equation for that. And I know that the image of the plot is shown below, and I know that each unit is equivalent to 5 feet. So what does that mean? That means each one of the little boxes on the grid is equal to 5 feet. So I have to remember that. That is 5 feet right there. So if I'm talking that there's 10 boxes, that's actually 50 feet, because 10 times 5 is 50. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50 feet. So let's look at our jobs. So our jobs are right here. Job one, I need to determine the perimeter of the building. So just as a reminder, perimeter is all the way around. So what I essentially have to do is find out how long it is all the way around, meaning I have to find each length and then put them all together. Then I need to determine the location in coordinate form where the statue stood in the center of the building. So I need to find where is the middle. So I'm going to have to figure out where is the middle of this rectangle of the building that represents the base of the building. And finally, I need to determine the location in coordinate form where the statue stood that was outside the building once stood. So I'm going to have to figure out where that stood exactly, because I'm doing an archaeological dig. I need the exact coordinates to help me figure out where I need to possibly look for the statue and what I need to do. So now we're going to break down what we actually need to do math-wise. So for my first job, I need to find each side length, as I already highlighted. So side one is AB. I'm going to need to find each side length. So I need to find AB, BC, CD, and DA, D to A, and we're going to do that using the distance formula. I also have to remember that whatever I get, I'm going to have to multiply by 5, because what I get will just be using the coordinates, but I have to remember that I have to multiply by 5 to get the true length. So that's something I'm going to keep in mind. Then multiply by 5 to get the true length, and finally then add them all up. So that's perimeter. So for job 2, I need the middle, so I'm going to have to find what's the halfway point between D and B and A and C, because if I find the halfway point of any of the outside sides, that's not going to be the center. The center is going to be where those two invisible lines intersect. So I need to find the midpoint of each between D, B, and A, C, and then C using the midpoint formula, and then find out if they're the same to make sure I did my math right. So I'm going to find the midpoint of DB and AC, and I need to know that these should be the same. And I will be using the midpoint formula. And finally, I need to find the location in coordinate form where the statue outside of the building once stood. So for that, I'm going to be using the reverse of the midpoint formula with A and B, where B is the midpoint, A is an endpoint, and we need to find the other endpoint. So we're going to reverse the midpoint formula with A and B, where A or B is the midpoint, A is an endpoint, and we need to find the other endpoint. All right, so now, last step here, before I can move on to the next page, I'm going to need the coordinates of each of my vertices of my rectangle here. So I'm going to go through and I'm going to label my coordinates. So A is 6 over 9 up. So that's 6 comma 9. Now something I want to remember is that the X is first, and that's horizontal distance. Y is second, and that's vertical distance. So I always want to count over and then up, or over and down, whichever direction, whatever quadrant I need to be in, always starting at 0. B is 9 to the right and 6 up, so my coordinates are 9 comma 6. So X, Y. C, 4 to the right and 1 up, 4 comma 1, X, Y. And D, 1 to the right and 4 up, so that's 1 comma 4, X, Y. These are going to be really useful in all of my formulas throughout this project. So I want to make sure I have them, and I also want to make sure that I write them down on each page that I'll be using them. So I always like to write them so I have them right in front of me. A is 6, 9. B is 9, 6. C is 4, 1. And D is 1, 4. So now I can start doing my job of finding the perimeter of the building. So I'm going to be using my distance formula. I have my graphic organizers right in front of me. They make it nice and simple. I'm going to find the length of AB. So I know A is 6 comma 9 and B is 9 comma 6. So that's where having these guys there and labeled makes it very easy. If I'd missed the label, I wouldn't know what to put where. So having the label, very, very important. Now, I want to follow the distance formula. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Well, I got to know what to plug in. Well, if I go through and I label, okay, point 1, that's x1, y1, because I know every point has an x and a y. Point 2 is x2, y2. It's my second point. It has an x and a y, but that's the second x and the second y. Now I just need to follow. So all I have to do is replace. x2 is in that first blank. x2 is 9. x1 is in the second blank. x1 is 6. y2 is in the next blank. y2 is 6. y1 is in the last blank, y1 is 9. So now it's just a matter of order of operations from here on out. 9 minus 6 is 3. 6 minus 9 is negative 3. 3 squared, 3 to the second power. That means 3 times 3. We're multiplying a number by itself. That's what the power means. So 3 times 3 is 9. Negative 3 squared is equal to negative 3 times negative 3, which is also 9. Then I add them up. 9 plus 9 is 18, and now I do my square root. So the square root of 18 is 4.2. So I write that down. Now I have to remember to multiply by 5, so I'm going to get that 4.2 times 5, and that's going to be my final AB, length for AB, so 4.2 times 5 is 21 feet. So I know that AB is 21 feet long. So that's my first side length. Now I just have to keep doing this with the rest of my sides. My next side length is BC. So I know B is 9, 6. So that's my first point now, 9, 6. And I know C is 4, 1. So I'm going to put that in my next section, 4, 1. 4, 1. And x1, y1, x2, y2, and I will go ahead and plug in. So x2 is 4, x1 is 9, y2 is 1, y1 is 6. 4 minus 9 is -5. 1 minus 6 is also -5. -5 squared, -5 times itself is 25. So I know it's the same for the second one. 25 plus 25 is 50, and I will put this in my calculator, and I find out that the square root of 50 is 7.1. But I have to remember to multiply by 5. 7.1 times 5 gives me 35.5. So I know that BC is 35.5 feet long. So that's my second length. Now I just keep on moving. Now moving on to find the length of CD, because that's the next side length. So CD, C is 4, 1, D is 1, 4. C, 4, 1, I'm going to label that already because my first point is x1, y1. D is 1, 4, that's going to be my x2, y2. And then I go ahead, plug in, and start moving. So that's 1 minus 4, x2 is 1, x1 is 4, y2 is 4, y1 is 1. So it's 1 minus 4 and 4 minus 1. 1 minus 4 gives me -3. 4 minus 1 gives me +3. -3 squared, -3 times itself is 9. 3 squared is also 9. So I'm starting to see a pattern of my AB length. 9 plus 9 is 18. I already know that the square root of 18 is 4.2. I already know that 4.2 times 5 will give me 21. So I know that CD is going to be 21 feet. And then finally, I'm going to do DA. So DA is, D is 1, 4. That's my x1, y1. A is 6, 9. That's my x2, y2. And then I'm going to go ahead and plug in. So x2 is 6, x1 is 1, y2 is 9, y1 is 4, 6 minus 1 is 5, 9 minus 4 is also 5, 5 squared is 25, the other 5 squared is also 25, 25 plus 25 is 50. I already know, based on my problem above, that the square root of 50 is 7.1. I remember I have to multiply 7.1 times 5, but I already know that the answer to that is going to be 35.5 feet. So now I'm going to add them all up. AB plus BC plus CD plus DA, all 4. So I know I'm adding up AB plus BC, thank you, plus CD plus DA. Well, AB is 21. BC is 35.5, CD is also 21, DA is 35.5 again, and when I add all those up, I know 21 plus 21 is going to be 42, 35 plus 35 is 70, so 42 plus 70 plus another 1, so it's 42 plus 71 because 0.5 plus 0.5 is 1. I could also just throw that into my calculator. But when I add them all up, 42 plus 71, that gives me 113 feet all the way around. So now I know my first perimeter, so I'm done with my first problem. The perimeter of the temple is 113. Now I'm moving on to job 2. So job 2 once again involved points, so I'm going to write down A, B, C, and D as coordinates so I can have them handy and not have to keep flipping pages. A 6, 9, B is 9, 6, C is 4, 1, and D is 1, 4. So now I just need to find the midpoint because job 2 is determining the location where the statue in the center of the building once stood. So I just have to find the midpoint of AC and the midpoint of BD for this. So writing my points down, A, 6, 9, C this time is 4, 1, and I know that the midpoint formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So those two don't have to end up adding up together. The x's stay with the x's, the y's stay with the y's. As always, x1, y1, x2, y2. I go in and I label. So this time I'm following x1 is 6, x2 is 4, y1 is 9, y2 is 1. 6 plus 4 is 10, 9 plus 1 is 10. 10 over 2 is the same as 10 divided by 2. 10 divided by 2 is 5, both times. Not going to change. So my midpoint for AC is 5, 5. I just need to make sure it matches with my midpoint for BD, and that's the exact center of the temple. So B is 9, 6, going ahead and labeling that x1, y1. D is 1, 4, x2, y2. So I go ahead and start plugging in. x1 is 9. x2 is 1, y1 is 6, y2 is 4, 9 plus 1 is 10, 6 plus 4 is 10, starting to look similar, right? So now 10 over 2, 10 divided by 2 is 5, 10 divided by 2 is 5, so do my midpoints match? Yes, if they match, I'm good. If they don't match, I have to go back and see where I went wrong, and then they're both the same, so the statue in the center of the building once stood at coordinates 5, 5. All right, so now this one, part 3, I have to determine the location in the coordinate form where the statue outside the building once stood. So this one's my hardest one. I know that I'm using A and B, but this time I don't know what my endpoints are. I only have one endpoint. So I know that point 1 is going to be A because that's my endpoint. That's 6, 9. So I'm going to call that x1, y1. But my midpoint now is B. My midpoint is 9, 6. So this time I don't get to plug everything in. I'm going to have to take things out. So let's go through this. First, I put my midpoint outside, 9, 6. Then I plug in my x1, 6. I plug in my y1, 9. But I don't know my x2 and I don't know my y2. Those are what I need to find. So this is what needs to happen. This is what I need to do my algebra for the goal of finding x and y. So what I need to do is take the x's of all of this situation and turn them into one equation, which I will do. So 9 is by itself outside, and I just copy down 6 plus x2, and I'm going to be solving for x2. And then I'm going to take the y's in my other situation and deal with them on the other side in the y coordinate section. So 6 is going to be outside again. And I have 9 plus y2 over on this side. So I have my x coordinate, I have my y coordinate. So I just have to think, order of operations, what is happening to the x? Well, first 6 is being added to it, then it's getting divided by 2. So when I go to reverse all of this, the first thing I need to do is reverse that division by 2. How do I do that? I multiply by 2. So I multiply both sides by 2. And when I do that, these 2's cancel out. And 2 times 9 is 18. 6 plus x2 stay together. So now I just need to get x2 by itself. Well, 6 is positive. I can move it by subtracting because it is attached to the x2 by adding. 6 minus 6 cancels out. 18 minus 6 is 12. So x2, the coordinates, the x coordinate of my endpoint is x2. Then I just need to do the same thing with my y coordinate. So same deal. Start separating them out. Okay, 9 plus y2 divided by 2. Last thing happening is dividing by 2. First thing I do is divide by 2. Cancels out on the right. 2 times 6 is 12. I get 12 equals 9 plus y2. Then I just have to cancel out the 9. Same way, subtracting on both sides. They cancel out. 12 minus 9 is 3. So 3 equals y2. And then all I now have to do is plug them in. I know coordinates are x and y, so my x coordinate is 12, and my y coordinate is 3. See what I did over here. So then now I have the answer to the final part of my problem. So that is my example for how to go through this project, solve all the problems, and make sure that you are doing the right thing throughout to show that you understand how to use midpoint and distance.